Welcome back to my channel, Cambridge Muneeb. So, in today's video, I shall continue from second part of the previously created video of October number 2021, paper 1, variant second. So, previously we had completed up to question number 21, up to question number 20. Now, we shall continue from question number 21. The question states which statement comparing magnesium and barium or the compound is correct. Before continuing with the question, you can find out the part number 1 of this exam of this past paper in the description and comment section. Okay, so here the first statement says that magnesium should react with hydrochloric acid more rapidly. So no, according to the literature, as we go down the group, then the reactivity of the group 2 metal increases. So it should not be more rapidly, instead it should be less rapidly, because magnesium should show reactivity less than barium. So this statement becomes incorrect. Now the next statement B says 1 mole of magnesium carbonate gives off a greater amount of gas when it reacts with an excess of hydrochloric acid. So basically there is no difference even if we take magnesium carbonate or if we take barium carbonate, because in terms of the compounds they have equal reactivity. There is no difference in them. However, if they are in the form of the metal, then definitely there will be some difference in terms of the reactivity. So there is no difference right now. The C statement says the solubility of magnesium sulfate in water is greater than the solubility of barium sulfate. So yes, that is so. I can show you through my notes as well. Alright, so here you can see the solubility of group 2 hydroxides and sulfates. So in this page you can find out that as we go down the group, then solubility of group 2 sulfate decreases. So as a result of this, we will say that the solubility of magnesium sulfate is more than the solubility of barium sulfate. So going back to the question, then C statement is correct, as the solubility of magnesium sulfate in water is greater. So yes, C is correct option. Then D say magnesium carbonate undergoes thermal decomposition less readily than barium carbonate. Now again, for this purpose we have to look into the literature what they say about the thermal stability. So it is mentioned here again in my notes that as we go down the group, then the thermal stability of the group 2 carbonate increases. So stability of group 2 carbonate increases down the group, which means it is more difficult to decompose the carbonates of the elements present down the group. So in this way, this D statement becomes incorrect. It should be written as more readily. Down the group, stability increases. So when stability increases, then it means magnesium carbonate will be more easily decomposed. So the only right option becomes C option. Now the next question is colors of the silver halides AgCl, AgBr and AgI differ. So the solubility of these halides aqueous ammonia also differ. So we have to compare the colors of the salts of silver with these halogen. So AgBr is the salt of the Ag. It is this salt. So we know that AgI is yellow in color. AgBr is cream in color. So both option A and B are correct in this case. And the solubility. So we should know their solubility as well. If we add dilute NH3, then AgCl will be soluble easily. If we add concentrated NH3, then AgBr will be soluble. So it indicates that solubility is decreasing accordingly. And when we again add so constant ammonia in AgI, then it isn't soluble. It remains insoluble. So according to this, the most soluble in the AgI versus AgCl is AgCl, since it can even dissolve in dilute ammonia. So the option A becomes the correct answer. Now the next question is question number 23. The name chlorate is used for an anion consisting of chlorine and oxygen. So we should know that there are two types of the chlorates present when there is a reaction of the cold NaOH and hot NaOH reaction with the chlorine molecule. So going to the literature, we can find that in case of the cold NaOH, in case of cold aqueous NaOH, the chlorate form is NaClO, and when there is reaction between hot concentrated NaOH with Cl2, then it is NaClO3 form. So we have these two types of the chlorates present. So I should write here ClO and ClO3. Now here we have the oxidation numbers of chlorine. So chlorine is plus 1 over here, since oxygen is minus 2, and then the oxygen in this ClO3 is minus 6. Minus 2 times 3 gives minus 6, whereas chlorine shall become plus 5 here, plus 5. That's why the full form is basically NaClO, and it is NaClO3, and on them we get neutral form of both compounds. Now we have found the oxidation state of chlorine in ClO and ClO3. Now the statement says that within the molecule of ICl, the iodine oxidation number is indicated by X. So if we check this, chlorine, we have to find out the electronegative trend. We know that going down the group, fluorine, chlorine, bromine and iodine, the iodine has the highest value of 4.0 electronegative value, and chlorine is 3.0, iodine is 2.5, which means comparing I and Cl is more electronegative, which means the concentrate on chlorine should be minus 1 and on iodine should be plus 1. Now we have found that value as well. So it says that X represents the oxidation state of iodine, which we mean to say we can write plus 1 here, plus 1 for the iodine, and the Y value indicates the oxidation state of chlorine, so it should be written minus 1. Okay, now they are saying that what value of X or Y is correct. Okay, so X is the same as the oxidation state number of chlorine in the chlorate form when Cl2 is added to NaOH. So if we check here, then X is plus 1. We already know that X value is, I will write X is equal to plus 1, and when it is cold NaOH, then the oxidation state of chlorine is also plus 1 according to here. Then I will write ClO. Cl has plus 1 here. So yes, both are same values. Plus 1 in the X of chlorine in the chlorate, and X is basically the value in ICl. So both are plus 1 over here. So these both statements are correct. But if we check statement B, that X is the same of chlorine, which we know as plus 1, but it is should be equal to hot NaOH, which means ClO3, but here chlorine is plus 5. So plus 1 and plus 5 are not same. And Y is the value of the iodine. So iodine is X represents the whereas the Y indicates the value of the oxidation state of the chlorine in ICl, so it should be minus 1. So minus 1 over here. However, in case of cold dilute, then chlorine has plus 1. so they are not same. And Y is already -1, but in hot concentrated Cl is +5. They are not same. So in all B, C, D option, there is no similarity between the oxidation state. So the only correct option becomes A, in which the oxidation state of the X is +1, which indicates the iodine. It indicates iodine, and it is same to +1 of the Cl in ClO. Now question number 24. Which statement is correct? The first statement says that ammonium is basic due to lone pair of electrons. So no, ammonium is written as NH4 plus. Now in this case, it is not a basic component, instead it is an acidic, since this one can provide hydrogen ions in the reaction along with formation of ammonia. So the substance which can provide hydrogen ions is called an acid. So it is acidic, not basic. So this is incorrect statement. The B statement is nitrogen monoxide reacts with peroxyethyl nitrate to produce a common photochemical smoke. Peroxyethyl nitrate is basically PAN, PAN, and its chemical formula is written in my notes, so you can find here. PAN is basically CH3 C triple O NO2. So I can write here CH3 C triple O NO2. Basically, PAN is produced by the reaction of nitrogen oxide with a component of photochemical smoke. Now, which component is there of photochemical smoke? That is unburned hydrocarbons or VOCs. We call them VOCs or unburned hydrocarbons. So unburned hydrocarbons could be any mixture of the hydrocarbons in the fuel. So it is written here that how they are produced. These are largely unburned hydrocarbons from fuel, and their oxidized products VOCs react in sunlight with oxides of nitrogen to make PAN in the photochemical reaction. So VOCs react with the oxides of nitrogen, which could be NO, it could be NO2, both, to make the PAN compound. So, and it is also diagrammatically mentioned here that the oxide of nitrogen, when react with the VOC, which is a part of the component of the photochemical smoke, it is a component of photochemical smoke. So they combine with each other to make PAN. So in this way we can say that this statement becomes incorrect. We should write that for NO reacts with a component of the photochemical smoke to produce the PAN. That in this case that could be the correct answer, but this is not. In current scenario, the words are interchanged, so B becomes incorrect. C option says nitrogen dioxide catalyzes the oxidation of atmospheric sulfur dioxide. So yes, that's the case. We can find the same thing in my notes, that NO2 is acting as a catalyst to oxidize SO2 to SO3, because NO2 is regenerated in the second reaction. So yes, that is the real sense, that it acts as a catalyst. And the last is nitrogen is very reactive due to the very strong permanent dipole attraction. So no, that is not correct. Nitrogen is basically unreactive because of the presence of the nitrogen to nitrogen triple bond. They exist triple covalent bond between two nitrogen atoms. Nitrogen means N2. So this is a molecule of N2. So they exist triple bond. That's why it is unreactive. So D is incorrect in this case, in this sense. So the correct option is C option. Now question number 25. It is the first question of the organic chemistry. It says how many of the carbon in this are sp2 hybridized. So we have to look carefully which carbon atoms are showing sp2 hybridization. We know that this carbon is sp3, not sp2. This is also sp3. but this carbon is sp2. It is bonded through double covalent bond, and there are 3 atoms bonded with each. With this carbon, we have this carbon 1, 2, and 3. When there are 3 carbon atoms bonded with the one particular carbon, then that particular carbon will have sp2 hybridization. So this is the one. And then we consider this carbon as well, which has sp2 hybridization, since it is connected with 3 carbon atoms, 1, 2, and this one is third carbon. And then this carbon is also sp2 hybridized, since it is bonded with 3 atoms, and those 3 atoms are 1, 2, and 3. So yes, that's also there. And this carbon is also sp2 hybridized. We have 3 atoms bonded with this carbon, 1, 2, and this one is 3. So we have now these carbon atoms termed to be sp2 hybridized. This cannot be the carbon to be sp2 hybridized, this one, since it is bonded with 2 atoms only, 1 and 2. So it cannot be the sp2 hybridized. Instead it is sp hybridized, and this one is also sp hybridized. Now what about this carbon? This carbon is basically bonded with 2 carbon atoms on either sides, this one and this one. So as a result of this, it is not sp2, instead it is sp hybridized. It is not sp2. So the only sp2 hybridized are these ones, sp2 1, and then 2, 3, and 4. Only these 4 are the ones which are sp2 hybridized. So the right option becomes B. Now question number 26. Compound X is found in cell walls. Okay, so we have this organic compound and we have to determine the stereoisomers of this compound. So basically, if we look at this structure, we can find that this side can make cis and trans isomers. That is possible here. Now if we check this part of the organic compound, then we can see that this carbon is bonded with 4 different groups. Those 4 groups are hydroxyl group, and then hydrogen atom, this whole molecule, and then this molecule, and up to the complete left part. So complete right part, complete left part, this OH and this hydrogen, these are all connected with this central carbon atom. So this can be considered to be the optical carbon. This is an optical, or we can say this is the asymmetric carbon here. This is asymmetrical carbon. Now we can find another asymmetric carbon or chiral carbon, which is this one. This is all optical or asymmetric carbon. How is it that it is bonded with this hydrogen, it is bonded with this hydroxyl group, it is then bonded with this whole right chain, and then it is also bonded with this whole left chain. So in this case we have now 2 chiral centers. I am labeling them with the red color asterisks. So these 2 are the asymmetric carbon atoms or chiral carbons. Now we have 3 different situations. We have 1.4 cis trans, and then we have 2 optical isomers. We have 2 asymmetrical carbons. As we know that one cis trans, if there is a carbon to give cis trans or geometrical isomer, we get two isomers as a result of this one, and we get 2 optical isomers because of one asymmetrical carbon. We get 2 optical isomers, and there are 2 asymmetric carbons, which means we should get 4 optical isomers, but that is not happening here. We should know that if we consider one cis compound, then that cis compound is containing 2 asymmetrical carbons. It has two asymmetrical carbons, which means we are getting 4 optical isomers as a result of these two asymmetric carbons. And then for a trans isomer of this molecule will again have two asymmetric carbons. These asterisks represent the asymmetric carbon. So again we have 4 optical isomers. So in total we would say that we have 4 plus 4 isomers of this compound. First 4 coming from the cis form and the other 4 coming from the trans form. Only then we get the right answer, that is the D option. So we wouldn't say that has in total 6 as a result of one optical isomer, one cis trans and 2 asymmetric carbon. So no, that is not 6. The right answer is 8, because for every cis we have 4 optical isomers, for every trans we have 4 optical isomers. Now question number 27. We have to construct as many structural isomers as we could through this molecule. So we should have a straight chain as well. So I'm going to construct the straight chain isomers of this compound. So instead of showing the chlorine atoms, I will make it simple by symbolizing the chlorine with the asterisks. Here asterisk mean the chlorine atom bonded on this carbon, and I'm not showing the hydrogen atoms to make it simple, since they just require a straight chain, so it makes easier to construct straight chain with asterisk. These asterisk doesn't mean they are asymmetric carbon, instead it means they are bonded with the chlorine. So this is the first isomer. Now second isomer will be look like this. I have to construct the positional isomer of this straight chain, which means now the carbon atoms are present, the chlorine atoms are present on carbon number 1 and carbon number 3. So the chlorine atoms are represented by these stars. And then another combination or another situation can be when the chlorine atoms are present on the terminal carbon atoms. These are called terminals, which are present at the ends. So these in this way I get 3 different isomers. Another possibility could be in which the central 2 carbon atoms have the chlorine atoms bonded on them. This is the fourth isomer. Now I have just selected the 2 different carbon atoms. What about if I select single carbon atom here, not 2, which means I should have 2 chlorine atoms present on the first carbon atom. This could be the 5th isomer, and the 6th isomer is when the 2 chlorine atoms are present on the second carbon atom. So this is there. Now I cannot make 7, because let's suppose if I choose to have 2 chlorine atoms on the far right carbon, then it means the same as this one, because it becomes one first carbon atom. And in the same way I cannot select to have 2 chlorine atoms on this carbon, since it will make the same like this structure in which they are present second carbon from the left. So in total I just have 6 different combinations to have these structural isomers of this molecular formula. So A is the right answer. Now question number 28. What is true of every nucleophile? We know that nucleophile contains the lone pair of electrons to attack. So there is only one option. It cannot be a single atom always, since it can be a molecule like OH negative. It cannot be the double bond. It cannot be negative charges. Ammonia is also a nucleophile without a negative charge on it. So these are not the correct options. And A, it has a double bond, that is the property of the electrophiles, not the nucleophile. So the only right option is B option, and it is the repeated question from these 2 variants, which you can look up at in the YouTube channel, in the YouTube. Now question number 29. We have the reaction between H, Br and this molecule. So if we apply the concept of Markovnikov rule, which is based upon the stability of carbocation. We know that, and it is implemented by Markovnikov's rule, which means the H should go on the carbon containing the less hydrogen atoms. So here, in this case, uh, this part has hydrogen should go to that carbon which has more hydrogen atoms. So this part has one more hydrogen atom over here, and there is no hydrogen on the left carbon. So this would go over here, and Br will go over here like this. So which means the molecule should look like this. It should have CH3 here and Br over here, and the double bond is omitted since we now have two hydrogen atoms over here. Now in the second part, it must have such a reagent which could replace this bromine with the OH part. So it is only the aqueous NaOH which could replace this Br with the hydroxyl group. We cannot have cold dilute KMnO4 since it doesn't attack on this compound. We cannot have ethanolic NaOH since this would produce alkene, not OH part over there, and hot concentrated could not be there since it does not produce the reaction because of this type of the molecule. So the only right option is part A. And we should know that cold dilute and hot concentrated NaOH, KMnO4, both of them react on this molecule. The cold dilute and hot concentrated, they both react on this molecule. They do not react on this product S. They have no reaction on this product S. Now question number 30, and this question is repeated 3 times in May June 2007 and May June 2017, and then in the specimen paper 2022. So we have these conversions. Now how the conversions are being done here: bromine is replaced by the CN, which means it has been reactive with the nucleophile providing a CN. It cannot be HCN since it is more harmful to use HCN directly since it is a toxic compound. So instead we prefer to use salt of the CN in the presence of the alcohol. So this is the reagent which is required. You can have this whole inside in my lecture notes of the ES chemistry. You can get these notes in PDF form if you need so by letting me know in the WhatsApp number or the comment section. So you can find that nucleophilic substitution reaction with cyanidines in ethanol. So the haloalkane compounds can react with the can substitute with the cyanidine if they use KCN or NaCN in the presence of the ethanol, and this is done under reflux. So yes, in this case we find that B and C are the right options, B and C from the first column. Now after producing this, we have to convert cyanidine into the carboxylic acids. So which means we have to convert directly into the carboxylic acid, and you can find the same reaction in my notes that we can convert the cyanide ions into the carboxylic acid by reacting in the presence of the hydrogen ions which comes from the acid. So that's how we get the carboxylic acid directly. So HCl and HCl both are correct from second column. So in this way the right option becomes the C option. Now next question number 31. The table indicates reagents and the reaction conditions required to make the compound 2-chloro-2-methylpropane. So basically I should first write the structure of this 2-chloro-2-methylpropane. It looks like this: carbon, 3 carbon atoms in a straight chain, and second carbon atom must contain chlorine and also a methyl group. Now we have to make this compound from the given conditions. So if we look at the first reagent which indicates that HCl is reacting with this compound, so we should have a clear structure of this compound. So I'm going to write this structure separately. C is double bonded with the carbon. Along with that, it has two hydrogen atoms over here, one CH3 over here, and another CH3 over here. Now it should react with the HCl. Now this one should again be followed by Markovnikov addition reaction, which means that hydrogen must go towards the carbon which contains more hydrogen atoms, or it should go over here. So when it will go over here, and chlorine must be added on the carbon. So the product form shall be H3C with CH3 on above, and chlorine should go below, and then CH3. So it is the same structure like this one. So yes, the first statement is correct. Now the second statement says it is a reaction of this compound with SOCl2. Now this reaction is basically a nucleophilic substitution reaction. Now again we must have a clear picture of this compound, so I'm going to draw this structure separately. It looks like this: CH3 with CH3 on top, OH below, and CH3. Now when it reacts with SOCl2, then it at room temperature, then we do have the nucleophilic substitution reaction, which means it should replace this OH with the Cl. So instead of OH there should be Cl, which means it is again representing the same molecule like this one. They are same. So the second option is also correct. The third option says we have a reaction of this compound with Cl2. So I'm going to draw this structure: CH3, then C bonded with H, and CH3, and then CH3. Now when it reacts with the chlorine Cl2 molecule in the presence of U villi, then there is a possibility that chlorine of any of this whole structure can be replaced with a chlorine. It could be these three hydrogen atoms, any one of these three hydrogen, any one of these three, any one of these three, or in fact it could be this hydrogen as well. So there is a possibility that the chlorine has substituted this hydrogen which I have encircled. So if we replace chlorine over here, so you will get the same structure like this one. So they are all producing the structure which we require: 2-chloro, 2-methylpropane. So in this way, all the three possibilities are there which are correct in a sense. So A is the right answer. Now question number 32. What are the only structure formed when butane 2-ol is heated with concentrated sulfuric acid? So for this purpose, we must have a clear idea of the reaction of butane 2-ol. Alright, butane 2-ol looks like this structure. It has alcohol on second carbon. Now when it reacts with the H2SO4, then it means it is showing the dehydration reaction, which means there is a removal of hydroxyl group from here, and a removal of hydrogen atom, but that hydrogen atom could be from the adjacent carbon atom of the COH, which means it could remove either this hydrogen or it could remove this hydrogen. So let's suppose if it removes this hydrogen which I have crossed out here, then you will get a double bond over here. But if it removes the hydrogen of this side, then it should have a double bond between these two carbon atoms, not the right one. So there could be either double bond over here, or it could be double bond over here, in which we have now two different possibilities. We can have a carbon double bond between these two carbon atoms, or we could have carbon double bond between these two carbon atoms because of the different scenario of the hydrogen removal. If you see clearly here, then if we have this type of structure, then it could make cis trans isomer, since it has a hydrogen over here, it has hydrogen over here, and methyl groups on the either sides of the carbons, which means both the carbon atoms of carbon-carbon double bond have the same type of the groups attached to them. They both have hydrogen atoms and they both have the methyl groups with them. However, in case of the first scenario, you can see that there are two hydrogen atoms bonded on this carbon, which means it cannot give It cannot give cis trans isomers since we require two different groups, but they should be similar to the other carbon double bonded carbon. Alright, which means we can now look at the structure which are present here. Now over here they are okay, we can now say that we have now three different products. Two products are formed as a result of this compound since they can form cis trans isomer, but there is only one product from this compound since it cannot make cis trans isomer. So all those options which contains only two products, they will be eliminated. We do not have two products, instead we have three products. Now we have to check which three products are there which are the right ones. So here we can see that as a result of the hydrogen to be removed from the carbon which forms cis trans isomer is we had OH over here, and when we remove hydrogen from this carbon we got cis trans isomer. So here the cis trans isomer are present here, this one and this one. They both are cis trans isomers, and then this structure is the one which is produced when the hydrogen was removed from the first carbon instead of the other carbon. And if we check D option, then in D option we do not have cis trans isomer over here, neither here nor here. They are but there is cis trans isomer here, but there is no cis trans isomer here. So they are the product, but these are not cis trans isomers. So the only right option is B option. So B is the right answer. Now question number 33. The compound leaf alcohol is partially responsible for smell of new mown grass. This question is also repeated. Okay, now what happens when this compound is reactive with the hot K2CO2O7? It should be kept in mind that the effect of carbon-carbon double bond is by the cold dilute KMnO4, or it could be hot concentrated KMnO4. There is no effect of the hot acidified K2CO2O7 on carbon-carbon double bond, which means we have to look for the other functional groups which are present here. So yeah, it can affect on the OH. It can oxidize alcohol into carboxylic acid. So we have to look for those compounds in which there is just an effect on the alcohol part. So double bond is here, it is not affected, it is still there, and the carboxylic acid is produced here. So this is the only right option among these four options. So C is the right answer, whereas other options are not right since we do not have any effect on the double bond. So this becomes incorrect, and there is no breaking up of a compound from the center. It is incorrect, and also this one is also incorrect. Now question number 34. We have such a compound X which can give these properties. We have to choose from these four options. It says that X does not react with tolerance reagent. So if we look over here, then option with the compound B does not give tolerance reagent because it doesn't have the group which is because it doesn't have the aldehyde functional group, because only aldehyde can give this type of the reaction. So aldehyde is not a B option. And which other compound? We have the C. C is the ester. C cannot give this compound of tolerance reagent test. So C is also the compound. And then the alcohol in the D option, it cannot also give the reaction. We should have the aldehyde for this test. Now the point B says form the yellow precipitate alkaline I2. Okay, now which compounds are there which can form yellow precipitate? It is A, the ethanol. Yes. In my notes, you can find the topic of the triiodomethane test, which has this type of the precipitate formation. Now here in this topic, you can find that which compound can give this triiodomethane test or the iodine. Among primary alcohol, these are only the ethanol which can give this test. Among the secondary alcohol, only those compounds can give which have OH group on the second carbon, so that the other carbon must have the methyl group over there. It should be a methyl group. Among the aldehydes, only ethanol can give this test, and among ketones, only methyl ketones can give this test. So by applying this rule on the given question, we can find that yellow precipitate could be given by the compound A, and it can also be given by compound B since it is the methyl ketone. It can give this test. So B is the one, and then D, it is the one which has a hydroxyl group on the carbon which is next to the CH3 carbon. So this CH3 is here. So yes, this can also give the test with the iodine. This is basically the iodoform test. Now the point D say it does not react with the sodium. So aldehyde cannot give with the sodium. A is there. The ketone of the B cannot give this test, and the ester cannot also give this test. However, the alcohols can give test with a sodium atom, because alcohols have slightly acidic properties which are comparatively less acidic than the water. So you can find my notes, the reaction of the sodium metal with the OH of the alcohol. So this is the reaction, and you get sodium ethoxide. You can have these notes in the PDF form by sending a request in the comment section or WhatsApp message. So in this way we have mentioned or enlisted all the compounds. So if we see here, there is only C compound which is present in all of the option. This is only B option, my mistake, not C. This is only the B compound which is present in all of these points, A, B, B, B. So B is the right answer. Now question number 35, which compound can undergo nucleophilic addition reaction? So basically we have to know that which reactions are able to do that. It can give free radical substitution. It can give the electrophilic addition reaction. Ethanol and bromine, this can give nucleophilic substitution reaction, whereas this compound can give nucleophilic addition, and it is mentioned in my notes as well. Here it is a reaction of the aldehydes and ketones which comes under the carbonyl compounds, and you can see the nucleophilic addition reaction with the HCN. So this can give reaction with any other nucleophile, and here is one reaction over here of the propanol with HCN. So it is a part of the nucleophilic addition reaction. So the right option becomes B option. Now question number 36. This reaction reacts with the acid, and the product formed from this reaction are reacted with LiLH4 to form two molecules Y and Z. We have to identify those. So if we know that this reaction with the acid means it is the de-esterification reaction, which means it is breaking up of the ester compound to make the alcohol and carboxylic acid back from where the ester was produced. So I should write a structure of the compound. So we should know that the carbonyl part is present here, and the alcoholic part is present on the right side. So left side is the carboxylic acid, and the right side is the alcoholic part. So the carboxylic acid should become C2H5 and COOH. This is the carboxylic part of this ester, and the alcoholic part is the one carbon atom, which is alcohol. So it should become CH3OH. This is the alcohol produced as a result of this deesterification. Now these must be reacted with the LiAlH4, and we should know that this is a very strong reducing agent and it can reduce the carboxylic acid. So when it will react with the mixture, it should attack on the carboxylic acid only, and there should be no attack on the alcohol. So the only reaction is between carboxylic acid, so it should be converted into the alcohol. It will first convert into the aldehyde. And then it will further reduce into alcohol, and we have only the options of alcohols here. So the alcohol produced from this reaction will be C2H5 and CH2OH. So this is the alcohol, that is the propanol. So we will look for the products. We now have these products formed as a result of this reaction. We have this propanol and we have this methanol. So methanol is present here, it is present here, it is also present here, and the other alcohol is propanol. So the propanol is present here and it is also present over. So no, there is no other position where this propanol is present. So it is not ethanol, and it is neither the secondary alcohol. So the only right option is the D option, because it has both the parts, the propanol and the methanol. Now next question is 37. A sample of propanoic acid reacts with magnesium and with sodium, and we have to check that which volume of the gas is produced. So basically we have to have good equations of the propanoic acid with both metals, Mg and sodium. First of all, I will construct the equation of the propanoic acid with magnesium, because it shows this reaction first. So propanoic acid is basically carboxylic acid with 3 carbon atoms, so it is written as CH3 CH2 COOH. Now it reacts with the magnesium, and as a result of this there is a formation of salt of magnesium plus hydrogen gas. So it is the acid at metal reaction. So CH3 CH2 COO with 2 plus magnesium and then H2. Now this is the reaction of this compound, but we have 2 moles of this compound, which means we have to put 2 over here. Now the reaction is balanced. And then reaction of the propanoic acid with sodium metal. So it is written like this: CH3 CH2 COOH plus sodium, and as a result of this, again we have a salt of the sodium, so it is called as sodium propanoate, CH3 CH2 COONA plus H2. Now to balance this equation, we should have one hydrogen atom over here, which means I will write half of O2. So it is also balanced now. So when magnesium is reacting, we get 2 moles of the propanoate ion, but when sodium reacts, we have 1 mole of the propanoate ion. But in case of hydrogen gas, then magnesium produces 1 mole of H2 gas, but sodium produces half mole of the H2 gas. Now we are given mass of the propanoic acid, and it is same in both the reactions. Okay, now for this purpose, we should have to convert the mass into moles, because we are supposed to find the volume, and for this purpose we must have the value in terms of mole. So the molecular formula of the propanoic acid, if we look at this structure, it is C3H6 and O2. C3H6 and O2. Now the MR value of this compound, if you calculate from the calculator, you will get 74 gram per mole. Now this is the MR value. Now I have to convert this value into the moles. So moles of the propanoic acid, will be mass is given 3.7 divided by 74. Value is equal to 0.05 mole. Okay, now I have got the value, but I need to know what volume of gas is formed with magnesium and what volume of gas. The gas over here is the H2 gas and there is no other gas formed. So which means I should get the moles of the hydrogen first and then convert that mole into the volume. So if I take equation first, which is the reaction of magnesium with the propanoic acid, if I write it as equation first and this is the second equation. So in equation first, I have the relation between the propanoic acid and the hydrogen gas. Since I have calculated the mole of propanoic acid, so I have to calculate the mole of hydrogen gas. So propanoic acid versus hydrogen. Over here, the stoichiometric equation shows 2 moles of propanoic acid and 1 mole of hydrogen, and the calculated value of propanoic acid is 0.05, and for this it will become X. So X will be equal to 0.025 mole. So this is the mole of the hydrogen gas produced. Now convert this mole into the volume. They have mentioned STP. STP stands for standard temperature and pressure, which means the temperature is 0 degrees centigrade, at which the volume is basically 22.4 dm cube or 22,400 cm cube. It is mentioned in the data section. You do not need to remember the values. You can get this value from the data section, which is the first page at the last, along with the periodic table. So 0.025 into 22,400 is equal to 560 cm cube. So as a result of the reaction with magnesium, you get 560. Now I have to calculate similarly for the second reaction, which is with the sodium. So for second case, I will do the similar calculations. Propanoic acid reaction with the ratio with hydrogen. So with sodium, I have 1 mole of this and I had half mole of the hydrogen gas. And the calculated value of propanoic acid is again 0.05 ratio X. So X will become, now X value will be equal to 0.05 divided by 2. So the same calculation here, 0.025 mole, and it will again produce same volume of gas because 0.025 into 22,400 gives the same 560 cm cube value. So I have the same volume in the second column as well. So in this case, the right option becomes the option A. Now question number 38. Which statement about this compound is correct? Okay, so here if this reaction is hydrolyzed, then as a result of the hydrolysis, there should be the formation of OH over here and there should be OH over here. We have two OH over here. So this is not a type of a secondary alcohol, since we have the primary alcohol as well. So it will not just produce secondary alcohol, and it is also said to be oxidation by KMnO4. So not just secondary alcohol is there, but there is also primary alcohol as well. So A is not the right answer. The B option says it can be made using ethanoic acid and a suitable alcohol. Okay, so here this is the ester part here, and we know that alcohol should be this part, this should be the alcohol part, but the whole left part should be the carboxylic acid part. So carboxylic acid is this much long compound. It is not small compound, it is a long compound. So ethanoic acid cannot give this type of the ester. So this becomes incorrect here. Now, and it should be kept in mind that when we read it from this way, it should be CO2CH3 means that C is bonded with O and with O like this and CH3, which means the right part is the alcoholic part and the left part is the carbonyl part or the carboxylic acid part. That's why ethanoic acid cannot be the right answer. Now the C says it gives a positive with alkaline KMNO, alkaline iodo, which means iodoform test. So no, it cannot give iodoform test because it doesn't have the ethanol, it doesn't have the methyl ketone, it doesn't have uh, the secondary alcohol, and so these are all the options left, and it is not the primary alcohol as well, like the compound we have in the previous question. So none of the options give this iodoform test. Now the last option is that when treated with hot constant acidified KMNO4 should give this compound as one product. So we should know that hot constant KMNO4 contains acid as H2SO4, and hot concentrated means now that this part should be able to break the compound of this ester into two parts, since it contains the H2SO4, which means it can cleave this compound from here. As a result of this, we can have the alcoholic part left from here and the carboxylic part is on the left side. Now if we check this here, it should give this part as a carboxylic acid. We have the carboxylic acid over here as a result of this H2SO4. So carboxylic acid is there. Now since it is the KMNO4 in the hot concentrated form, it should give alcohols over here like this. So we do have the again there is a slight mistake. In case of the hot concentrated KMNO4, we should have a cleavage over here to make the carbonyl compound. So it should cleave from here, which means there should be carbonyl group over here. Now this carbonyl group, when further reacts with the acid, it should convert into the carboxylic acid. That's what we have learned in the alkenes, that this should convert into carboxylic acid as well. But since it is not the hydrogen over here, instead there is a methyl group over here, dimethyl group present here. So instead of carboxylic acid, it should only be restricted up to the ketone. This compound can only give the ketone. I can now make a whole reaction from this compound. I will write that this compound is like this one, H2C double bonded. Now this would break from here and there is a carbonyl group over here, and the right part should become oxygen double bonded with carbon like this, and it has CH3 over here, and then it continues with CH2, and then this part should be cleaved because of the presence of the H2SO4. So it should become C alcohol. First it will convert into alcohol, which will be converted into the carboxylic acid. So we have carboxylic acid on the right side like this, and we have the ketone part on the left part of it like this. So that's how we have this compound formed as a result of the treatment with hot concentrated acidified KMNO4. So both the oxidation of alkene is there and as well as breaking of the ester group from this single compound. So D is the right option here. Now question number 39. It is the repeated question. Synthetic resins are produced, can be made by this polymerization. So we have to check the repeating unit of this compound. So it looks like this compound it has OH group over here. Now we know that as a result of the polymerization can only be done by the addition of the carbon-carbon double bond. So only these two carbons should be involved in the formation of the polymerization. So we can say that it is like this. There is again a slight mistake. The propane 1 propane 2 in 1 all means that the OH part is on carbon 1 but double bond is present on carbon number 2. So we can conclude from here that it should be written like this. OH is over here, and this is CH2. Now this should be connected bonded with this carbon-carbon double bond. So whole of this CH2OH is bonded on this carbon. This whole part is present on this carbon, so it should become a side chain. Only these carbon double bonded with carbon should be there to make the polymerization. So we check from here. We can see from these given options that it should not be the carbon-carbon double bond in the repeat unit, and also it should not be the oxygen part in the repeat unit, and then there should be no 3 carbon atoms in the repeat unit, since the structure is being formed by these 2 carbon atoms, which means it should be linked like this. It must have CH2 OH, and then another monomer of this type should be linked with another compound, and we should have CH2 OH. So there should be only 2 carbon atoms in the repeat unit. So this is the only option which is showing the right structure. So B is the right answer. Now question number 40, and this is the question from analytical chemistry, especially the mass spectrometry. Now here we are given some values. We are given the values from where we have to calculate the value of abundance of M+1 peak. Okay, we have this molecular ion peak, which is considered as M plus peak. M+1 peak is given here. The mass spectrum of this compound is given. We have to find the M+1 peak abundance. So for this purpose, we should have this formula, which you can find from my notes as well. From my notes, you can see that this is the formula which we are going to apply. N is equal to 100 times abundance of M+1, which is in the ion form, plus ion form, and divided by 1.1 into abundance of molecular ion peak. This is called molecular ion peak, and this is M+1 peak, or the fragment which is M+1 and the fragment which is M+. Okay, so we do have the value of the abundance of molecular ion peak. This is the value which is linked with the molecular ion peak, and M by E values are given. So the formula is here. N is basically representing the number of carbon atoms in the molecule. N is the number of carbon atoms in the molecule. So for this purpose, we are given the compound, so we can check out how many carbon atoms are there. So this is first carbon atom, this is second, I write 1, 2, 3, 4, 5 and 6. So there are 6 carbon atoms. So we got the value of N as well. Now I will write the formula here. N is equal to 100 into abundance of the M+1 peak, M+1 ion, divided by 1.1 into abundance of M plus peak, which is called molecular ion peak. Okay, now we have to rearrange this equation to find the value of this one, which means we have to find the value of this part. So for this purpose, we rearrange this equation and it will look like this. n into 1.1. Sorry, we have to calculate the value of this one, which means we have to calculate the term in the numerator, not in the denominator. We have to find this term. So n into 1.1 into abundance of m plus ion divided by 100, and this will be equal to abundance of m plus 1 ion. This is what we have to calculate. So I put the values here. N, as we calculate, is equal to 6 and 1.1 is there. The abundance of m plus ion, it is given here, that is 7%. Molecular ion peak is 7%, so multiply by 7% divided by 100 is there, and it is equal to abundance of m plus 1 peak. So if you calculate this value, it shall give you 0.462%, that is equal to abundance of m plus 1 peak. So this is the right answer. So option A is the right answer. So this way I have completely solved the second variant of paper 1, October number 2022, October number 2024, and 9701. I hope you have got a good explanation of all the question, and it proved very beneficial and useful for you. If you like this video, do share, like, subscribe, and do send me any request or any queries you have. Till my next video, take care and bye bye, and Allah Hafiz everyone.